Hi, this is Mr. Shumway. This video clip is a quick review of exponential equations just to get it fresh in your mind. The percentage rate change for y equals 31 times 1.17 raised to the x is 17%. So 0.17 larger each time, 17% larger each time we multiply. Okay, so from a table of values, we could say, well, let's take the next value divided by the previous value. That tells us 1.2. And then if I want to know the starting value, I say, well, the equation is y equals some starting value times 1.2 raised to the x. We could use the second after two growth steps. We could say there are 298 times that equals the starting value times 1.2 squared. So then we can just solve by dividing by 1.2 squared. And that value is 207. So the one that matches there would be the second, would be B. Okay, say we're growing by 52% every 5 hours. And how many? They start with 256 bacteria after 18 hours. So it's not a whole number exponent. So if it was 15 hours later, that would be raised to the third power, but let's just go ahead and raise it to the 18/5. So y equals 256 times 1.52 raised to the 18/5. On your calculator, you're probably going to need to put that in parentheses to make sure that it does the division before it raises to the power. But we can do that, or you could even just get a decimal equivalent and raise 1.52 to that power. Okay, match that equation, that graph with an equation. Well, 4 raised to any positive power, like if x was 3, 3 minus 2 would be 1, would start getting positive values for anything greater than, well, they'd all be positive values, but certainly there would be large positive values, and there aren't large positive values there. They go negative as x goes positive. So let's go scroll down a little, see what some of our other options are. 4 raised to a positive x, and then subtract 2. That's going to be like 4 squared is 16 minus 2 is 14. That's not on the graph. Half of 16 would be 8. That's not on the graph. Here, that would get very large. If x is 2, that would be 2 plus 2 is 4. 4 to the 4th would be a very large positive number. But this next one here has a negative in front of the, outside of the parentheses in front. So we take 4, we square that, and we get 16. And then we take the negative, so that's negative 16. You can see that that graph matches that equation because all of those are going to be negative numbers. And they get very large negative. They go very far in the negative direction as x gets large. Okay, so if we wanted to find the starting value, they give us that these values are shrinking by 20% each time. We can just write an equation, some starting value times 0.8 raised to the x. We could use, when x is 2, y is 2,240. Starting value times 0.8 squared. Just solve by dividing by 0.8 squared instead of multiplying. 0.8 squared divided by 0.8 squared is 1. 1 times v is v. 2,240 divided by 0.8 squared is 3,500. They give us the starting value. They just want to know if what is the base raised to the power. So we take our 6,152, divide that by 4,732. That tells us 1.3. So that's just a quick review of exponential equations to get it fresh in your mind for the benchmark.